Hello, welcome to CAC 586 Introduction to AI. Let's start with the big question, what is artificial intelligence? It turns out there isn't just one definition, but where from the concept of artificial intelligence evolved. On August 31, 1955, this four gentlemen, John McCarthy from Dartmouth, Marvin Minsky from Harvard, Nathaniel Rochester from IBM, and Claude Shannon from Bell Labs, circulated a proposal for the Dartmouth Summer Research Project on artificial intelligence. In it, they coined the term artificial intelligence and proposed a 2-month, 10-man study for the summer of next year, which is 1956, at Dartmouth College, Hanover, New Hampshire, and sketched research aims like getting computers use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. The proposal sought Rockefeller Foundation support and served as the invitation to participants. The actual workshop ran in July to August 1956 and is widely treated as the field's formal launch. Now, what is artificial intelligence? It turns out that there isn't just one definition. Over time, researchers have looked at AI from different perspectives. From the Russell and Norvik's textbook, in their classic approach, they organize this perspective into 4 main approaches. The first one is thinking like a human, which is about trying to model how people actually think. This connects AI to psychology and cognitive science. The second is acting like a human. This is about building systems that behave in ways we would recognize as intelligent, like passing the famous Turing test. The third is thinking rationally, which is about capturing the laws of logic and reasoning to make correct inferences. This goes back to philosophy and formal logic. And finally, acting rationally, which is about designing agents that take the best possible action to achieve their goals. This is where much of modern AI research focuses today. So depending on which lens you use, AI might mean mimicking the human mind, imitating human behavior, reasoning with logic, or simply making rational decisions. Understanding these 4 perspectives helps us appreciate why AI is such a rich and evolving field. Now that we have seen the different ways of defining intelligence, let's talk about a central idea in AI, the concept of agent or intelligent agent. An agent is anything that perceives its environment through sensors and acts upon that environment through actuators. For example, a human agent has eyes and ears as sensors, and hands and legs and the vocal tracts as actuators. A robotic agent might have cameras or infrared rangefinders as sensors and motors as actuators. A software agent can receive keystrokes, files, or network packets as input and then act by displaying information on the screen, saving files or sending packets across the network. To formalize this, we introduce the idea of a percept. That's the input an agent gets at any given instant. The complete history of everything the agent has ever perceived is called the percept sequence. So how does an agent decide what to do? That's where the agent function comes in. Agent function maps the percept histories to actions. So it's a mathematical description that maps any percept sequence to an action. In principle, we could imagine making a giant table of every possible sequence of percepts and the action the agent should take. But in reality, this table would be impossibly large, maybe infinite even. That's why in practice we design an agent program. The actual implementation running inside some physical system. The program is what realizes the agent function. So that's the implementation of the agent function. So in summary, the agent function is an abstract mathematical mapping, and the agent program is the concrete code or mechanism that makes the agent behave that way. This separation between function and program is a foundational concept in AI because it lets us think both about what an intelligent agent should do in theory and how to actually build it in practice. Now let's consider the vacuum cleaner world. To make all these abstract ideas more concrete, let's look at a very simple example. This is from Russell and Norvik's textbook, and this is called the vacuum cleaner world. This is a made-up world, simple enough that we can describe everything that happens, but flexible enough that we can imagine variations. The world has just two locations, square A and square B. Our vacuum agent can perceive which square it is in, perceive whether that square is dirty or clean, and it can take actions like moving left, moving right, sucking up the dirt, or doing nothing. Now here is one very simple agent function. If the current square is dirty, suck. Otherwise, move to the other square. That's it. The simple rule already defines a working vacuum agent. When we look at the agent function as a table, we see that different vacuum world agents can be created just by filling in what actions to take. But this leads to an important question: what makes one agent better than another? In other words, how do we decide whether an agent is intelligent or not in this environment? That's exactly what we'll explore next: how to evaluate agents and define what counts as a good behavior. So there comes the concept of rationality. A rational agent is one that always does the right thing. But in AI, doing the right thing has a very specific meaning. What's rational at any moment depends on four factors: the performance measure, how we define success. Second is the agent's prior knowledge about the environment. Third is the actions it can take. And fourth is the percept sequence so far. Everything it has sensed up to now. Formally, we say a rational agent chooses the action that maximizes its expected performance given its percepts and knowledge. Like take the vacuum cleaner world. If the performance measure is 1 point for every clean square at each time step, and the agent knows the layout but not the dirt distribution, then the simple rule, suck if dirty, otherwise move, is rational. Suck if dirty, otherwise move. So rationality isn't about being perfect everywhere. It's about choosing the best action possible given the goals, knowledge, and perceptions available. Remember, when we talk about rational agents, we need to be careful not to confuse rationality with omniscience. An omniscient agent would know the actual outcome of every action before it happens. But that's impossible in the real world. Rationality is not perfection. Instead, rationality means choosing the action that maximizes the expected performance, given what the agent knows so far. So rational agents are not fortune tellers. They make the best decision they can with the information available at the time. This leads to two important ideas: learning and autonomy. A rational agent should not just react, it should also learn from its percepts, updating its knowledge as it gains experience. If an agent relies only on what its designer hard-coded into it and ignores its own experiences, then it lacks autonomy. A good rational agent should not just react, it should also learn from its perspectives, as I said. A good rational agent is at least partly autonomous. It learns from the environment to overcome limited or imperfect prior knowledge. For instance, a vacuum agent that can predict where dirt is likely to appear will perform better than one that only follows fixed rules.